Hello everyone, welcome to this new video. So here I will be implementing a C++ program where I will show how to implement a Regula Falsi method. If you want to know more about the algorithm, you can check out the video of the algorithm for Regula Falsi. I'll give the link of the video in the description of this video. So here I will just explain mathematically how this Regula Falsi is done accordingly and I will do the coding also. So let's get started. Okay, so this is the equation which I need to solve using Regula Falsi method. Okay, so first what I need to do is that I will have to choose two initial points A and B, and then suppose I am choosing 1 and 2, and then I will put it in the equation. So f of 1 will be how much? 1 cube minus 1 minus 1. So I got the value minus 1. Then f of 2 I will put, which I got 2 cube minus 2 minus 1 equal to 5. Now if you see the algorithm, I can proceed only if f of a into f of b is less than 0. So since one is negative and one is positive, so obviously their product is less than 0. So I can proceed to the next step. So this is about the algorithm. Okay. So now after getting, now I have f of a and b. Now I will apply the Regula Falsi formula to find out c. So c is our first approximation. So this is the formula of Regula Falsi. A value we know, a value is 1, b is 2. F of b we know, f of a we know. We will put it in the formula to find out the value of c, which is 1.1667. Then I will find f of c. That is, I will put this value of c in the equation. That is 1.1667 cube minus this minus 1. So we got this value. Okay. Now we are going to proceed only if f of c is less than the approximation, the tolerance value. If it is less, so we will take some small tolerance value. If it is less, then only we are going to go to the next second iteration. This is the first iteration. So same thing will be repeated. So in the so if we see in the algorithm also, now this is negative, right? F of c is negative. Then what was positive? F of b was positive. So f of b, the root lies between f of b and f of c, right? So we will change the value of c. So if you see, this is the c. If the root lies between f of b and this, we will make a equal to x of n. So we are going to change the value of a to c. So this is our new interval. Again we will do the second iteration. Okay. So this is how we are going to proceed. Now we will apply it in the C++ program. So how many variables we need in total? A, B, C. For sure we know that we need A, B, C. Then we need some value for variable to store the tolerance. So let's go to dev C++ and start typing the program. So in dev C++, first I will include the header files. So I will write down iostream and one more header file cmath I need, because I'll be using some mathematical functions. Then using namespace std. Now I'll give main. Now inside the main I'm going to declare my variables. So let's give double as the data type. So definitely I'll be needing 3 values a, b, c, as I have shown it in the example, and one more value tolerance I will need. Okay. So let's see, and one more thing, int maximum iteration, that is how many iterations I will be doing, and the iter value to keep a track of how many times my loop will be running. So first I'll write cout enter a and b. Then I will give the input the values of a and b. Then this a and then after that we need the tolerance value also. So I'll write down cout enter tolerance. So we will give a value and we will for whether to continue the iterations or not, it depends on the value of the tolerance. And then what else we know? We want to know how many iterations we will be doing. So we will enter here the maximum iter variable. Here we will be storing the maximum iterations. Now if we see the algorithm also, we will continue after entering the values of a and b. we need to check whether they are of opposite signs or not. That is, f of a into f of b is less than 0 or not. If it is so, then only we are going to continue. So what we will do is that we will just check if f of a into f of b is less than if it is greater than 0. So if it is greater than 0, what we are going to write? We will just write down C out invalid interval. Okay, we will write down invalid interval and we will return. Okay, and if it is not, then only, and if it is less than 0, then only we are going to do this. Okay, what we are going to do, we will see later on. Now here, since I have given f of a and f of b, I will have to define some function here. So let's define the function. It is going to return some double value. So I'll just write down f. Here also we are going to put some double x. So we will input some argument out there. And what is the formula that we have taken? X cube minus x minus 1, right? So we will use the same formula. Let us use the same formula. So it is going to return x cube minus x minus 1. Okay, so this is our formula. Okay, so till this part it is clear. Now we are going to write down what will happen if f of a into f of b is less than 0. Okay. Okay, so now we are going to find out the value of c. So this is the formula. So if this condition is false, then we are going to do this one. Okay, so this is the formula. If you see here in our algorithm, if you see, so this is the root approximation in Regula Falsi method. So this formula itself I have given here, c equal to a into f of b, fb in minus b into fa divided by fb minus fa. So after getting the value of c, if we are going to check if the absolute value of f of c, if it is greater than if it is less than less than tolerance value, okay, then what we are going to do, we will know that is the root. So we will just write down C out approx root is, so what is the value? The value of C is the approximate root, and we are going to return 0. Okay, so if this is the value of fabs of f of c is less than tolerance. Otherwise what we are going to do, we will go to the algorithm to see that again. Okay, so here if we see our algorithm, what is given here, you see. So now suppose f of c value is greater than tolerance, then what we will have to do, we will have to check this. If f of a into f of, here xn I have written, but it is f of c is less than 0, then we are going to make b equal to c. Otherwise we are going to make a equal to c, right? So this is what we are going to write here. So here I'm going to check if f of a into f of c is less than 0. F of a into f of c is less than 0. So f of a here in place of xn it is c. If it is less than 0, what we need to do? We need to set b equal to c, right? So we are going to set b equal to c. Else what we are going to do? Else we are going to make a equal to c. Done? So this part is done. Now after that, let's see what we need to do. Okay, so this is what we are going to do, and after completion of this entire thing, this one loop, right, our loop is starting from, okay, this do loop. Here we are going to make it iter plus plus, that is we will increment the iter when after checking the condition. So what is the condition? We will give the maximum number of iterations, right? So when iter is while iter is less than equal to max iter. So till we reach the maximum number of iteration, here the spelling is wrong. So till I come till here, I'll keep on going through the loop, and after going through the loops iterations also, if this condition is not satisfied, we are not going to get the root. So I will just write down cout method did not converge within the maximum iterations. Okay, now let's see how the program works. So this is our entire program. Let's see how it works. Okay, so I have saved the program. Now let's run it. So I'll go to execute, compile and run. Okay, so here we are getting one error. I forgot to give 0 here. Save it again and then you compile and run. So this time let's give the value of a and b as 1 and 2. Tolerance let us give at 0.001. Iterations you can give any value. I'm giving 50. So the approximate root is 1.3247. So you can check by giving the values. You can give different values also, but in order to see whether your program is working correctly or not, you can give the values of a and b as 1, 2, tolerance this, iterations this, and see whether it matches the approximate root or not. So this is all about regular falsi method. Thank you everyone.